All right, so I'm going to go ahead and start this recording. Welcome to our ninth learning workshop, and this will be over organic chemistry. I've written some of the rules for IUPAC naming, and now we're going to go through the levels of priority when numbering the longest carbon chain. So if I'm looking at this particular part requires you to recognize levels of priority when it comes to numbering. Okay, so the first level of priority is functional group. The second level of priority is going to be lowest numbers. Lowest number on the first branch. So that means basically you're going to number it from the side closest to the first branch, or first substituent. And then if branches are equally spaced out on either side, then you go to the third level of priority, which is alphabetical order. So that basically means alphabetical order basically means that number from the side whose first branch comes alphabetically first. And we'll go through examples of each of these. So let's go ahead and do a brief example of this type of naming. So let's say we have a compound like this. I'll change the color here. Okay, so, and of course I'm going to go ahead and add the hydrogens because this will be a condensed formula. Oh, by the way, that's another thing. When you're drawing these compounds, every carbon tends to have 4 branches. So every carbon tends to have 4 bonds. So whatever bonds are not shown are going to be bonds to hydrogen. So this top carbon has 1 bond, so that means it should have 3 hydrogens. This carbon has 2 bonds shown, so it means it has 2 hydrogens. The next one has 3 bonds shown, so it means it has 1 hydrogen. The last one has 1 bond shown, it needs 3 hydrogens to get a total of 4. The one over here has 2 bonds shown, so there'll be 2 hydrogens there. And the last one has 1 bond shown, so there'll have 3 hydrogens there. Okay, so let's look at this. If I'm looking at this, I want to start by looking for the longest carbon chain. So how many carbons are in the longest carbon chain? Okay, this is 5. Anybody else? Do you agree with her? I don't understand. I can't quite hear you. Leanne
I
says
don't
6.
I don't understand how you said you were getting the carbon chain or something. How did you get all of that? 3, 2, 3, 2, 3. How did you get all of that?
Oh, the number of hydrogens? Well, the number of hydrogens is based, I'll show the carbon bonds first, but carbon always has 4 bonds. So, like for example, in the case of this carbon here, it has 1 bond that's shown. Well, it has to have a total of 4 bonds, so that means it must need 3 hydrogens to have a total of 4 bonds. And this one carbon here, it already has 3 bonds that are shown, So I have to put one hydrogen here to give it a total of 4 bonds. In the condensed structure, you don't show bonds to hydrogen. Does that make sense? Okay, so Leanne was correct in that this is 6. Remember, the longest carbon chain is not necessarily going to be a straight line. So when you're looking at the longest carbon chain, one way you can do this is by looking at what I tend to refer to as the junction carbons or the intersections. The intersections here are going to be carbons that are bonded to more than 2 other carbons, okay? So this one's bonded to 3, this one's bonded to 3. So these are your intersection carbons. So you want to go the two longest direction from intersection. Now, for this first one here, it doesn't matter if I go up or to the left, it's 1 carbon either way. But I have to go to the right because that's going to be much longer. So I will go ahead and capture that one here, and I'll call the other one my branch. Now I get to the next intersection. I want to go in the longer direction. Do I go forward or do I go down?
Down.
Down. Down, there's 2 carbons that way, so I have to go down this way. And there you go. So I see that this is actually a 6 carbon chain. The longest carbon chain is 6. So that means that the root name of this compound is going to be hexane. Now, do you all know what the first 10 hydrocarbon names are? Methane, ethane, propane, etc. Okay. So this is going to be hexane. So now everything that's not part of the longest chain is going to be a branch. So I'm going to circle those branches separately. Okay. So I've got 2 branches here. I've got 2 branches here. Now, which side am I going to start numbering from? Well, I don't have a functional group, so I'm going to have to go to the next level of priority, which is the lowest number on the first branch. So which branch? Yeah, the closest. That's going to be closer because if I numbered it this way, it would be 1, 2. If I numbered it the other way, it would be 1, 2, 3. So 3 is larger than 2. I'm going to go with the lower number. I'm going to start numbering it from the side on the left because that's closest to the first branch. Okay, so let's number the rest of them. So that's 1, 2, 3, 4, 5, 6. Okay, so now I have a branch on carbon 2 and a branch on carbon 4. And what's a 1 carbon branch called? What's a 1 carbon branch called? All right, methyl. Male. All right, methyl. Yep, it's methyl. Spelling counts in this, so you gotta be careful, guys. All right, so 2 methyl. So this is 2, 4. So it's going to be now. If you have more than 1 branch of the same kind, you need to put a prefix to indicate how many you have. So this is going to be 2, comma 4, because remember we put commas between numbers and numbers. Commas go between numbers and other numbers. And then I put a dash because a dash goes between numbers and letters. 2, 2, 4, di, because there's 2 methyls. Dimethylhexane. And there's no spaces. No spaces. So 2,4-dimethylhexane. So this would be your name for that particular compound. Does that make sense? There we go.
No.
Cool. All right. Let me know if you have any questions. All right. Is it okay if I erase these notes? Y'all got them down?
No, not yet. Hold on.
Okay.
I'm not following at all.
In the meantime, I'll put up another example, but I am going to need to clear the screen
Okay.
eventually.
I'm done. Thank you.
Oh, you are done. Okay, cool. So, what if I have a compound like this? Let's see. Okay. 2CH2. All right. So for this compound, what's the longest carbon chain? How many carbons is it? Yep, it is a hexane. It is 6. This one you can, if you want to, just go straight across. Now, which way would I start numbering this? Left. Why? Why would I use the left instead of the right? In both cases, they're only 2 away, right? So yeah, if I numbered it from the left, it would be 2-bromo. If I numbered it from the right, it would be 2-methyl. So it's a 2 in both cases. The numbers are the same either way. So the lowest number rule, no, bromine's not a functional group actually. Bromine is just a substituent. So it's not a functional group. So because bromine is just a substituent, we have to go to the third level of priority, and the third level of priority is alphabetical order. Bromo comes before methyl. Since this one would be called a methyl, and this is a bromo, then this would have to be numbered from this side because the B comes before M. Does that make sense? So this is 2-bromo dash 5-methyl hexane. Does that make sense? Any questions on that? Okay. Let's dive into let's dive into another example here. Let's say we had something like this. What about if we had a compound? Oh, I'm going to change my color to red. What about if we had a compound like this? And we did this. Uh-huh. See, now I'm getting a little creative. Yeah, that looks fun. Okay, so what about if I had a compound like this? What's the longest carbon chain? Maybe you can circle it for me. You guys are able to draw on this, so I don't know. Who wants to circle it for me? Leanne? Carissa? Who wants to circle for me? Circle the longest carbon chain. I'll tell you if it's right. You can even do it anonymously. I won't even know. Okay. So let me ask you this. Would it have been possible? You're not wrong, but would it have been possible to also do it like, yeah, that way? And it's tricky, but the answer would have been no. Now, why could you not go down like that? Why do you have to go across? It has to do with the branching of the chain. So you always want to go in the direction of the more branched chain. So remember when I mentioned the junction carbons? So here's a junction carbon. It's bonded to, well, actually it's not. It's only bonded to two. So that's not a junction carbon. It's not an intersection. It's not an intersectional carbon. Here's an intersection carbon, and here's an intersection carbon. Now, if I'm going across here, I know that this is going to have to be, I go one, or I actually don't know which way I'm numbering yet, so I'm actually going to take that one off. But if I'm going across here, 1, 2, 3, 4, I can either go 5, 6 or 5, 6. Which direction is more branched? This side or down? The side to the right would have more branches, right? Because it splits. This doesn't split, so this, if I go this way, I'm not going to have any branches off of this one. So whenever I have to choose a direction, I always have to go in the direction of the more branched chain if the chain is equal in length. Now, if it's not equal in length, I always go in the direction of the longer chain. But if the in this case, the longest chain would be the same, it would be hexane or hexane. Well, which way do I go? In the direction of the more branched chain. Does that make sense? Do y'all see that? Give me some feedback, people. All right, cool, thanks. All right, so now, having done this now, I realize that I have three substituents, three branches. I have this one, I have this one, and I have this one. Now, which side am I going to start numbering from, the left or the right? One says the left. What do you rest of you say? Do you say left too? Or do you say right? Frank says left. How about you, Linda? Left?
I don't know any. I don't know this topic. Is hard for me.
Oh, that's okay. I'm sorry, I don't mean to put you on the spot. All right. So yes, actually, this is not going to be on the left. I have to number from the right because remember, the first level of priority is the lowest number. So this is if I number from this side, I get 1, 2, 3, 4, 5. So I have 2 is the first substituent. Now if I number from the other side, I'll use a purple color. 1, this will be my carbon number 1 down here. This is 2, and this is 3. So you can see that in both cases, the first substituent, the first branch is on carbon number 2. However, if the first branch is the same, I have to go to the second branch. Where's the second branch? Well, if I number from the right-hand side, the second branch is on carbon number 3. If I number from the left-hand side, the second branch is on carbon number 4. So numbering from the right gives me lower numbers. And since bromine is not a functional group, and this is why that designation is important, and Frank, you're not totally wrong. I know that there are some that kind of consider these halogens to be functional groups in a sense, but they actually are not classified as functional groups in the name as far when it comes to naming. So, um, so this is going to have to be numbered like this: 1, 2, 3, 4, 5, 6. So I only go to that third level of priority if the numbering would be the same either way. In this case, the numbering is different. I'm going to take off these orange numbers because those are not correct. Any questions on that? Does it make sense why I chose to do it that way? Okay. So now we're going to go ahead and name this. Now when we name it, what comes first? Well, first we might want to go ahead before we even start naming it is to actually write the names of the substituents. So this is a little bromo. This is bromo. This is methyl. And this is ethyl. I have a bromo, a methyl, and an ethyl. Bromo, methyl, and ethyl. Okay, so I have a bromo, methyl, and ethyl. So what happens? How do I start the naming process? So you might think that you would name it by whichever comes first, as far as number-wise, like a 2-methyl. But it turns out that you actually, when you're naming it, you have to name it in alphabetical order of the substituents. So even if we don't number in alphabetical order, which we did not, we went by the lowest numbers, even if we don't number in alphabetical order, we have to name in alphabetical order. So the first thing that's going to have to be written is 5-bromo. 5-bromo. And what comes after 5-bromo? What do you think? 3-ethyl. Ethyl comes first because E comes before M, right? E comes before M in the alphabet. So 3-ethyl. And then 2-methyl, right? And then how do we close this up? What's the last thing we say after we've named them all? Yeah, hexane. So that is the name. An ungodly name to be sure, but 5-bromo, 3-ethyl, 2-methyl, hexane. So because, well, it's 3-ethyl, but because this ethyl group here, E comes before M, so the alphabetical order of the substituents is B, E, M. So bromo comes first, then ethyl, then methyl. And we have to give the number that is the location of each one. So the bromo group is on carbon number 5, so it's 5-bromo. The ethyl group is on carbon number 3, so it's 3-ethyl. And the methyl group is on carbon number 2, so it's 2-methyl. Does that make sense? Okay. All right. So I want to actually share something with you, and I want you to take a stab at working on this one. I want you to take a stab at working on this one on your own, and then we'll come over and we'll check it together. So I'm going to share this with you. Where's my Let's name these compounds. Name. There we go. Name these compounds. As soon as it loads. You don't have to do all of them. I just want you to do the first one. Do the first one, and you can zoom in if you have trouble seeing it because you're not going to be able to see it at the current zooming. So just zoom in a little bit, and it'll become clearer. So do number one, and let's see if you get it right. Oh, and raise your hand when you're ready. If you have it. Oh, good. You already have one. Okay, two. Excellent. How about you, Frank? You, you can also raise your hand if you give up. Okay. All right. So, so Leanne, would you mind taking us through what you did?
You said me?
Yes, if that's okay with you.
If I have it right. I don't know if I have it right. Okay, so I started off by numbering the chain from right to left.
Okay.
One
Can you
through six.
can you circle the longest chain?
Oh. Oh, never mind. I'm already wrong right off the bat. So
Oh.
one, two, three, four, five, six. Yeah, I'm already wrong because it's seven and I got six. So
Okay. Well, no. Now that you know it's seven, can you circle that seven carbon chain?
okay.
Okay. Did anybody else get that? Krista, did you get seven? Oh, okay. Well, yeah. So it's a little bit tricky. You have to really kind of watch. Like I said, look at those intersectional carbons. Okay, those intersection carbons. And actually, I hate to say it, 'cause I was kind of evil with this particular one. Um, but there's actually more things to consider than just the longest chain. So this is an intersection carbon, and this is an intersection carbon. So you're right that this is seven. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But now, and of course, with this intersection carbon, this is a one carbon branch. This is two carbons up here, and this is like four. So this obviously it's gonna be obviously up and over this way are your two longest directions. But when I come to this one here, well, this is obviously 1, 2, 3, 4 up here, so it has to go this way. But I also have to look at the other one. If I go to the left, it's 1, 2. If I go down, it's also 1, 2, isn't it? So which direction am I going to go? Should I go to the left or should I go down?
I would think you should go down.
Why should I go down?
That looks more stylish.
I'm not saying you're wrong, but why? Why would I go down instead of going left? because you're actually right. You should go down, not left. Why? Why should I go down and not left?
Because then the drawing looks like a car.
You're a little hard to hear. I'm sorry.
Never mind. I said because then the drawing will look like a car.
The triangle looks like a car. No, it's because we have to go in the direction of the more branched chain. Go in the direction of the more branched chain. So if I go down, see how it splits again? I go in the direction where there's more splitting. This is actually an intersection carbon too. As a general rule, all of your intersectional carbons will usually be in the longest chain. Not always, but usually. So yes, in this case, it's tricky, but in this case, you will want to go like this.
Wow.
Now, so I want you all to not feel bad about this because I will tell you that almost no one, and I do mean almost no one, ever gets this right. Okay, when they first go through it. When they first go through it. So yes. So now I'm going to go ahead and circle my branches. I have one branch here. Anything that's not part of the longest chain is a branch. One branch here, one branch here. So now, which direction am I going to start numbering first? Where am I going to start numbering first? From the left side or the right side? I have to start numbering from a CH3. Yeah, from the left, because that side's going to be closest to the first branch. If I number from the left side, it's going to be 1, 2, whereas from the right side, it would be 1, 2, 3. So the third carbon that has a branch. From the left, the second carbon has a branch. So this is 2, and this is 3, 4, 5, 6, and 7. Okay. So now do you think we can name this? What would the name be? Help me out, people. I believe in you.
What
What
did
would
you
the name
say?
be? What would the name be? I said, help me out, people. I believe in you.
Oh no. I don't know why it's just hard for me to just even picture it in my brain. I'm not picturing it. That's a problem.
It's okay. Like I said, it takes practice. It takes practice, but breaking it up into these pieces will help. We identify the longest chain, we circle the branches, we number the longest chain, and then we can start to name it. Let's start with the names of the branches. So what's the name of this 2-carbon branch on the left? What's that called? And you can either turn on voice or you can type it into the chat. But what's the name of the 2-carbon branch on the left? Yeah, that's going to be an ethyl. Very good. And it's going to be a 3-ethyl. So you're right. You're right. So this is 3-ethyl. Okay. What about the methyl here? Oh, I already gave it away. But yeah, this is going to be 2-methyl. 1-carbon branch. And then, of course, this is a 5-methyl because it's up there. You're very close. Remember, when we list out our substituents, we list them in what order? What order do we list them in? Alphabetical, that's right. So which of these branches is going to come first? There we go. So we'll start this as 3-ethyl. 3,5-ethyl? You probably had a typo there. Yeah. So it's 3-ethyl, and then since we have 2 methyl groups, we don't write 2-methyl and 5-methyl. We're going to say, we're going to put them together. We're going to do the 2, comma, 5. And then what do we put after that? 2, comma, 5 what?
Metal.
Not
That
methyl. We have to put a prefix, right? Dimethyl. Dimethyl. Very good. And you were right. The only thing is you put septane, and the prefix would actually be heptane. That's a really good guess, because sept, it does mean 7, but the IUPAC uses heptane. It would use a hept prefix rather than a sept prefix.
good.
Very good, very good. All right, I want to give you guys another chance at this. Go ahead and tackle the second problem. Go ahead and tackle the second problem. Give that a shot. And raise your hand when you're done, or when you give up. All right, we got one person, or do we have 2 persons? Somebody raise their hand and then put it back down. Oh, okay. All right, I'll give you a little longer. Frank, you got one? Or is this more like a give up answer? Okay, gotcha. All right, we'll give you guys a little bit more time.
Hey, good. Oops.
All right. Okay. All right, let's go ahead. Let's go ahead. We can go ahead and go over it if you like.
Oh.
You guys are too funny. Okay. So did anybody have an idea for the longest carbon chain? How many carbons was in the longest carbon chain? Okay. So y'all are still not looking at the intersectional carbons, right? Should be 6, yeah. So look for the intersectional carbons. So the intersection carbons would be the ones that any carbon that's connected to 3 or more carbons. So this first one is not. This is only connected to 1. This is connected to 2 carbons, so that's not. This is only connected to 2 carbons, so it's not. This is connected to 3. 1, 2, 3. So I'm going to have to underline that one. And then and then this one only connected to 1, this connected to 1, this is connected to 2. So you only have 1 intersectional carbon. So you're going to look for the 2 longest ends, the 2 longest branches out from this carbon. Well, I could either go this way, though that's just 1 carbon on this side. And I could go down, there's 2 carbons on that chain downwards. And I could go to the left, 1, 2, 3, there's 3 carbons this way. So I go with the 2 longest directions. 3 carbons this way, 2 carbons down, and I circle the longest carbon chain.
Michael.
Yeah.
Like you're talking now, I think it's beginning to make some sense. I would have just appreciated it if you could just tell us how, like when you were talking just now, it began to make a little bit of sense to me, in the sense that, okay, you said the carbon chains, that also means that when you see these hyphens, you have to count where the hyphens are coming from and how they link to each other for you to be able to get the chain. So
Well,
if you
you're
put,
looking for the carbons, not the hyphens. The hyphens
okay,
represents bonds, but you're looking at the carbons themselves.
yeah. So how do you know which carbon is what? That's what I'm saying. Okay, like for instance, you say 5 or you say 6, and I'm wondering where did that 6 come from? I don't know. So I'm
Well,
just looking.
see if so. This is basically it's like this. You can either count one, two, three, four, five, or one, two, three, four, five, six.
Mm-hmm.
So you can go in any direction you want, but you have to go in the direction of the longest chain. And so I'm trying to help you see how you can figure out where that longest chain is. Does that make
Mm-hmm.
sense?
Yeah.
So in this case, I have to go, one, two, three, four, five, six, because that's longer than one, two, three, four, five. Think of it as a rope with many knots, okay? If you want
Yes.
to make the rope as long as possible, you're going to grab the two ends that will make it as long as possible.
Okay.
This is a shorter end than this. This has a longer piece of rope attached to it. This is a shorter piece. So I take the two longest pieces of rope and then pull it out and stretch it out.
Okay.
Anything that's not part of the longest
Mm-hmm.
chain is going to be a branch. So this little chlorine is a branch. This CH3 is a branch. And the
Okay.
bromine is a branch.
Yeah.
Does that make sense?
Okay. So yeah, so what you're looking for the longest chain for you to be able to
Exactly.
get and for you to be able to name it and get your answer, right?
Exactly. You have to start with the longest chain. Exactly.
Yeah, it's beginning to make sense. So so when you do it like this and you say it's called is there so how did you get a you say 6 CH6 or C6 or what? Where do you get the
If
6 from the okay, see when you number okay you so you it, when it's when you want to name it that you have to look where would you start your naming from, where would your number one be? That would determine the name, right?
So that's the next part. Once you figure out what your longest chain is, you have to figure out which siding you're going to start numbering from. And
Okay.
that's where those levels of priority come in. So the first thing, if there's a functional group, you'll always start naming it from the side closer to the functional group. We're going to get into that in a
What
second.
is a functional group?
Now, a functional group would be something like an OH or a double bond. You haven't actually seen a functional group yet, okay?
Okay.
You will shortly, but you haven't seen a functional group. A functional group would be like a double bond or a triple bond or an OH or something like that,
What is a
okay?
double bond? What is a triple bond? That's the those are the small because
So,
the
so
thing
like
is
for
that
example, if the compound looked like this, like if this was a CH2 and you had a double bond between that and the next carbon, CH,
see,
and then, CH3, that functional group, this double bond here, this is a functional group. So wherever the double bond is, you always start naming from the side closer to the double bond. Or
okay.
always start numbering from the side closer to the double bond. So I would not start numbering it on this side. I would start numbering it on this side.
So when you see the hyphens, okay, I want to get one thing. So when you see these hyphens, if there are three, it's triple bond. If there are two, it's two bond. If it's one, it's a
Two
single.
is a double bond, three is a triple bond. Yes.
Ah, perfect. Okay. It's beginning to make sense when you break it down because for what I wanted to say is this, right? Even if we stay just one, even if we get the whole gist of this whole class in just 1 minute and that's all we spend here, it's worth it. We could spend 1 hour and we don't understand anything and we just completed 1 hour doing nothing. But if we
Yeah.
spend even 20 minutes, but we get everything that 20 minutes, it's totally worth it.
Oh yeah, and that's why I encourage you. Please ask questions. I mean, if what I'm telling you is not making sense, I want you to ask me questions because I want to make sure that I'm being clear enough for you.
Yes, thank you. I appreciate it. I really appreciate it right now.
Okay. So
True.
so that first level of priority I mentioned is functional group. That doesn't apply because I have no functional group. So the second level of priority is numbering it in such a way as gives you the lowest numbers on your branches. So which side am I going to start numbering it from to give me the lowest numbers on my branches? Am I going to start numbering from this side or this side?
Both of them has same numbers as their ending, so
Oh no, actually they don't. If I number from this side, this is
Mhm.
1, 2, 3. So I have my branches on so let's actually do a comparison. Let's number them both ways and we can compare them, okay?
Okay.
So if I number it from the left, this would be 1, 2, 3, 4, 5, 6. So this would be the branches are in carbons 3, 4, and 5. If I number it from the right, I'm going to use a purple color. This would be 1, 2, 3, 4, 5, and 6. So for if I number it in the purple color, if I number from the right, the branches are on carbons 2, 3, and 4. So from the left, they're on 3, 4, and 5, but from the right, they're on 2, 3, and 4. Which one gives me lower numbers? Which side gives me lower numbers, the purple or the red? What do you think, Linda?
I don't understand. No.
So, so look at where the first branch is, okay? Start with the first branch, okay? If I start numbering it from the right, this is carbon number 1, this is carbon number 2, right? Right?
Hmm.
There's a branch on carbon number 2, isn't there?
The bromo.
The bromo, yeah. And there's a branch in carbon number 3. And there's a branch in carbon number 4. So there's a branch in carbons 2, 3, and 4 if I number from the right. If I start numbering it from the left, this is 1, 2, 3. See, I don't even get to my first branch until carbon
Yeah.
number 3 if I go
Hmm.
from the left. If I
Yeah.
go from the right, my first branch is on carbon number 2. If I go from the left, my first branch is on carbon number 3. The one on the going from the left gives me my lower number on the first branch, so I have to start going from the left. Does that make sense?
Yeah.
Yes.
Yeah.
Okay. So now that I know which way to number it, I numbered it 1, 2, 3, 4, 5, 6. Okay. So 2, 3, 4, 5, 6. Okay. My branch. So now I'm going to start. I'm going to list my numbers in alphabetical order. Okay. I'm going to list my numbers in alphabetical order. Or list my branches in alphabetical order. Now, at this point, I can name it because I have all my branches identified. I have my longest chain identified, and I have my chain numbered. So if I'm going to name this, I'll start with my branches, and I'll go in alphabetical order because even though I don't number it in alphabetical order, I always name the branches in alphabetical order. So which branch would I name first?
The bromo.
The bromo. And what number is it on?
2.
2. So this is 2 bromo. Then what comes next?
The other CH3, there's
CH3 is a methyl, and there's also a
a metal.
Cl on number 4. Which one comes alphabetically next?
Metal. No.
The Cl actually, chloro. C comes before M.
Yeah.
The C
The
comes
chloro.
before M. I'm not looking at the CH. I'm looking at the name. CH3 is called methyl. I have to go by its name. So alphabetically, its name comes after chloro. So
Yes.
it's 4. The chloro is on carbon number 4, so I'll say 4 dash
Chloro.
chloro.
Yeah, 4 chloro.
And then after that is going to come
3 metal.
exactly 3 methyl.
Hmm.
And then now I've named all my branches. What comes after that?
How do you determine the name, the total name of everything?
Yeah, the root name. Okay, so I name my branches first. and then I give the root name of the compound, and the root name of the compound is based on the number of carbons and the functional group. If there's no functional group, it's just an ane, alkane ending. It's an ane ending.
Okay.
So yes, as Chris has said, it's going to be hexane because hex is the prefix that indicates 6 carbons.
Oh, I
So
see.
it's going to be hexane. The AN tells me that it's an alkane. In other words, it doesn't have a functional group.
I see.
Does that make sense?
Yeah, it's beginning to make sense. It's beginning to make sense because so what I understand now is that for you to start naming it, you first of all start naming from the branches. So the branches you have, and the branches have to be named according to alphabetical order.
Yes.
So then after you get the branches, then you now look whether you have a functional, what's it called? I don't know, functional something.
Functional
And
group,
then,
yeah.
yeah, if you don't have a functional group, then it means you just have one name that you're looking for, and then you go with that and get a root name. It makes
Mm-hmm.
sense. No, it makes sense. It
All
makes
right.
sense.
Are you guys brave enough to try number 3?
Okay, let's see. What who has the
Is it-
longest chains?
I mean, I can skip ahead. I can skip ahead and just start going over alkenes, but I think it might be good for you guys. So far, we haven't had any successful attempts at any of these problems, and I think it would be good for you to build some confidence because I'm thinking you all are starting to understand this now. You want to take a shot? What do you think? Otherwise, I can skip to the alkenes. What do you think, Frank?
I think
You
this
want to
was
give it
the
a shot?
hardest. Is for
Let's do number 3. Okay, go ahead and do number 3. I'll give you a minute and then we'll go over it together. All right, sounds good.
okay.
All right, looks like we got a few. So, what did y'all come up with? I see somebody marking on it, and I see a good identification of the longest carbon chain as being 5. That was well done. You got the longest carbon chain being 5. So, what did you get for your name? 2,3-dimethylpentane. That's awesome. Excellent job. You nailed it, my friend. You got two of those groups. And if you number the longest carbon chain, excellent, well done. 1, 2, 3, 4, 5. So it's 2,3-dimethylpentane. Excellent, excellent, excellent. Very good. All right. So let's go ahead and take a look. Let's go ahead and take a look at some let's see. Let's do let's go I'm gonna go back to the whiteboard. Okay, so here's the deal. We're gonna go ahead and look at alkenes. So when you're naming an alkene, when you're drawing alkenes and you're naming alkenes, you have to look at the where the double bond is, because the double bond is a functional group, so it's always the most important feature. So, for example, I'll go ahead and start with something like this, relatively simple. Okay, so I have CH2, and this is just going to be a CH, CH2. Here we go. So now all you have to do is number the longest chain. The longest carbon chain is 4. So what would the root name for that be? Exactly. Butene. So but is the root for a 4-carbon thing. Butane is a 4-carbon alkane. Butene is for a 4-carbon alkene. Because this has the double bond, it gets the ENE ending. But you have to not just give it an ENE ending, you have to indicate where that double bond is. So the double bond is between carbons number 1 and 2, because I have to start numbering it from the side closest to the functional group, right? And the functional group is the alkene. So I'm going to go ahead and start numbering it from the left side, because that's closer to the double bond. And it's between 2. I always go with a lower number. So this is going to be 1 butene. And that's it. That's all you have to do to name that compound. Does that make sense? So you indicate the location of the functional group and the ending. Now it gets a little bit more complicated once you start adding substituents, once you start adding branches. So let's go ahead and add some branches here. I have, let's see, I have a CH3, CH2, CH, double bond, CH, H2, CH, three, Br. I'm so evil. And good call, Chris. A good call. All right, so I am done. I'm done. Okay, so here's the deal. Which side am I going to, first of all, let's identify our longest carbon chain, okay? Before we do anything else, that's always the first thing we want to do. So let's identify our intersection carbons. Can anybody underline our intersection carbons, the carbons that are connected to 3 or more other carbons? All right, very good. So we got the longest carbon chain. And so all you have to do is go ahead, or rather you have the intersection carbon. There's only one of them. So what are the 2 longest extensions from that intersection carbon? Right, down, or left? Pick 2. Which way should I go? Oh, you're circling it. Good. Circle away. Left is 1. And then where should I go from there? Down or to the right? Down. Although that's not the end of the chain, right? You have to include that one too, right? Yeah, there you go. So that's part of the longest chain. All right, cool. So which side am I going to start numbering from? Which side am I going to start numbering from? Teresa says the right. What's the first level of
On the
priority?
right.
What's the
Huh?
first level of priority? The functional group. So which end is closer to the functional group? Which one will give you a lower number on your functional group? The left. You actually have to start numbering from the left. I told you I was evil. That's between 3 and 4. If you number it from the other side, it'll be 4 and 5. So this side gives you a lower number on your double bond, so you have to go this way. Even though it causes your substituents to have higher numbers, because the double bond is the first level of priority. So first level of priority, functional group. Second level, the lowest numbers. Third level, alphabetical order. All right, so now now we can, let's go ahead and identify our branches. We have the bromine, we have this methyl here. So what are we going to name this? Let's start with our alphabetical order branches. What do we say?
6-bromo.
6-bromo, very good. And then what comes after that?
You have 2 CH3s. That would be
Not
2
two, there's only one. There's only one. Only the orange one is the branch. The other one's part of the longest chain.
Okay, so 7 metal.
You mean 5?
Oh,
The
okay.
orange CH3 is
Oh,
connected
okay.
to
Oh, yeah.
carbon
This
and
one is
5.
part of it. Sorry. Yeah, that's 5 metal.
5 methyl, very good. So 6-bromo, 5 methyl. And then what do we do? Now we've got our branches done. Now we have to give the root name.
7. What is 7 called? Is it heptane? Oh,
Hep, no, it's it has an alkene double bond, so it's going to be called what?
7.
Heptene, yeah. And we have to give a number indicating where the double bond is. So this is going to be 3-heptene. So this
Why
is
is
going
it
to be
called 3?
6
Why is it called 3-heptane?
because the double bond is in between carbons number
Oh,
3
that's true.
and
Mm-hmm.
4. And I always have to go with the lower number, so it's going to be 3-heptene. I have to indicate where it is. So 6-bromo, 5-methyl, 3-heptene.
Okay. I have a question. My question is
Yes.
that how do you know it's heptane? How do you know it's heptane? How do you know it's peptane or whatever? Okay. Could you draw from 1 to 10? 1 is 2 is di, 3 is tri, right? Is that how you name that?
Oh, that is for your functional groups. If you have more than one functional group, you can have dimethyl or trimethyl
Have
or
tetra?
tetramethyl. That'd be 4 methyls. But the the root names of all the compounds, the base
Mm-hmm.
10 that you really need to know are methane. That would be a 1-carbon alkane. Ethane, that would be a 2-carbon alkane. Propane would be 3. Butane is 4. Pentane is 5. Hexane is 6. Uh, and then heptane is 7.
19, 18,
And then
20.
octane is 8.
Let me write. Okay.
Nonane is 9. And then there's decane. And you won't be asked for do anything longer than decane. But those are the base 10. Now the ending changes. That's the thing. The ending changes depending upon what the functional group is. And you'll learn different endings as we learn different functional groups. Right now, I don't know how far y'all have gotten in class. I know some of you have gotten a lot farther and some of you have gotten not as far.
Oh, we're still in gas. We're still in gas. Gas.
Oh, you're still in gases. Okay, so you haven't gotten here yet. But, oh, then you'll be ahead of the game when it comes. But, um, yeah. So this ending in ane is for if it's just an alkane. But if it's an alkene, if it has a double bond, then all of those endings would be ene.
Oh, I see.
And if
Okay,
it
yeah.
was if it had a triple bond, then it would be YNE. So the
Oh, I
ending
see.
changes depending upon what the functional group is.
It's you.
Does that help?
Yes.
Okay. So now let's take a look at. I do want. We don't have a whole lot of time left, but I do want to deal with cis and trans because that's something that confuses a lot of students. With the double bonds, many times they'll ask you for cis and trans, like to name it as either a cis or a trans. I'm going to erase this if that's okay.
Okay.
Okay. So the cis and trans is not hard. It's just about identifying a very simple pattern. So a lot of times when they do cis or trans, they're going to show it like this. Okay. They'll like maybe say, well, I have a hydrogen here and a hydrogen here, and let's say I have a CH3 here, and then I have a CH3 here, or CH2 and a CH3. Okay. The longest carbon chain, as you can probably tell, is 5. It's just this 5 carbon chain. Now, when for a double bond, if, and so I'm actually going to write this out because this is actually very important. If each, that means both double bonded carbons, if each double bonded carbon, if each double bonded carbon is, if each double bonded carbon is bonded to exactly one hydrogen, then it gets either a cis designation or a trans designation. And it basically has to do with where are the hydrogens. If the hydrogens are on the opposite sides, in other words, one is up, one is down. If the hydrogens are on opposite sides, it's trans. So if the H's are on opposite sides, we call it trans. So this molecule up here would be referred to as trans dash 2 pentene. This is trans 2 pentene because it's pentene because it's 5 carbons. I have 1, 2, 3, 4, and 5. I start numbering from the side closest to the double bond. And the double bond is between carbons 2 and 3, so I'll say this is trans 2 pentene. If, however, I was instead presented with a molecule like this, oh, what the heck was that? I'm going to fix that. If I was given a molecule like this, and the hydrogens were on the same side, see now you can see, if you're looking at this, now you can see the hydrogens are actually on the same side. They're both up relative to the other group that's with them. And so the longest carbon chain, of course, is still 5. Because it's a double bond, it locks the molecule in a position that it cannot change. It's locked into this position so that the hydrogens are always up. They're always forced to be on the same side. So when they're in the same side like that, we call it cis. So trans means opposite sides, cis means same side. So let me write this out. If H's are on the same side, now they can both be up or they can both be down, it doesn't matter. But if the H's are on the same side, then we call it cis. And so this molecule would actually be referred to as cis 2-pentene. Does that make sense?
Yes. It's two painting.
Cool. Should we do an example?
Hmm.
I know. Well, I guess we're out of time, but I don't know. I can do one example. We started a couple minutes late. You want me to do an example?
Okay.
All right. I'm going to give you actually. So let's say we have something like this. Okay. I won't make it too complicated. All
Oh
right.
God.
Do you want to try naming this on your own?
Okay, we have
Let's see. Okay.
we
Let's
have a
give that a
six.
stab.
We have where this. Where's the eraser in this place? There. Where do you have the eraser?
Oh, very good. So what do we call this monstrosity?
Trans.
It is trans.
Trans.
What comes
Trans.
after the trans?
6.
That is awesome.
Trans.
Yeah, trans 4-bromo 2-hexene. Y'all are awesome. Excellent. Well, I feel like I've at least gotten you a start on the right track. Let me let me share something with you really quickly. Share content, share application screen. Here we go. So on our Science Learning Center website, if you go under 1406 practice problems, I would encourage you to practice some of this a bit more because it does take a while to really get proficient at naming and drawing these compounds. So try drawing and naming alkanes. One, there's an answer key completed with it. There's another one, answer key completed with it. This is the rest of those hard ones that I was doing with you. There's the answer key with that. There's cycloalkanes, drawing and naming that. So there's lots of different things for you to practice here. I would encourage you to go ahead and practice those. Um, and if you have any questions on any of the more complex ones or anything like that, please feel free to stop by the Science Learning Center and we'll be happy to go over with you. We'll be happy to go over with you and help you figure those out. Sound good?
Yeah, sounds good.
All right. Well, thank you. Thank you very much for coming. Y'all have a wonderful week.